Right. Now,
So the same author's writing two mugs at the same time.
focus please everyone. Last week, I introduced the idea of logs. And now we're going to start thinking about logarithmic laws. Alright? So really remember, when you've got a to the power of x equals to b, the log
base A
of base a of b equals to x. Alright? So what we're going to do is here, you know that there's an exponential form. We know how to change it to the log form. And you know how to change it back as well. So what we're going to do today is thinking back what you've learned in year 9, year 10, year 11, the index law, to derive the logarithmic law. Important one is product sum, quotient difference, power scalar.
No.
And then derive and use the change of base law and use some of the logarithmic laws to simplify algebraic expressions. Now, so you don't need to write this down. You've got it in your handout. These are all the index law you should remember. Alright? I'm not going to go through it. So you need to think about a and b has to be greater than 0. And m and n is real. Alright? M and n is the power. And a and b is just the base. Alright? So you can have fractional indices as well. So there are whole number indices and fractional indices. Alright, now, let's start off with the law number 1. How do we change that to a log law? Alright, so if I've got x equals a to the power of m and y equals p to the power of n. So if we put it in terms of the logarithmic forms, you know log of a of x is actually equals to n. And log of base a of y equals to n. Alright? Now, how are we going to link a? We know that a to the power of m times a to the power of n equals to a to the power of n plus n. So how are we going to link this? Change that to the log law. So let's start thinking about if I've got a to the power of m times a to the power of n, is that since a to the power of m is x, a to the power of n is y, that is the same as that, correct? Yeah?
Yeah.
Now, linking, let's take it applied log of base a on both sides. What happened? So if I applied log of base a on both sides, so therefore log of a x times y equals log of a to the power of n plus n. Correct? So what is log of a to the power of n plus n? N plus n only. So here you need to know log x times y equals to n plus n. Alright? This is the first law that you need to know. Log xy equals log of axy equals log of ax plus log of ay. Alright? I think this is the basis of the slide rule. How they use it to do multiplication. But I think for slide rule they use natural log rather than base a or base 10 or whatever. Alright? So there's the first one you need to know. It's going to be in your formula sheet, so you don't have to remember. So log of axy equals log of ax plus log of ay. Alright? Happy with that?
One sec.
Yes.
Don't have to copy everything down, you'll get it eventually. You don't have to copy everything down, you just need to know that red box, that's all. Even the red box, you don't have to copy it down, it's going to be in your formula sheet. But it's handy to know, so that you don't have to refer to your formula sheet all the time. The next one is the quotient rule. Same thing. We will take the log of a, log base of a of x, and log base of log a base a of y, which is n. Alright? So now we can link the index law. You know what this is getting at now? So x divided by y is a to the power of m minus n. Since x is a to the power of m and y is a to the power of n. And applying log on both sides. So therefore, log of ax over y equals to m minus n. And the next one that you need to know, log of a x over y is log of base a x minus log of base a y. Alright? So multiply is plus, divide is minus. Pretty straightforward. Now the next one. I'm just only going to look at x to the power of m. X equals to a to the power of m, which means log a of x is actually m. Alright? Here, the index log a to the power of m to the power of n is a to the power of m times n. Alright? And log of a to the power of n. So therefore, x to the power of n is a to the power of n times n. Again, applying log a on both sides. You can see what I'm getting at now. Log a to the power of x to the power of n is m times n, and you know m is log ax. So therefore, the next one that you need to know is log x to the power of n equals to n times log x. So the three laws, it will all be in your formula sheet. I have not used log for many years, but I've learned all this when I was young and I still remember. Alright, so this is the waste formula sheet. You will get that. Now, this is like the index laws. They only apply in the same base. Alright, that's so important, same base. If it is different base, you can't apply. So all these three will be in the in your formula sheet. Now, the next bit you need to think about is, can you do that? Can you use all that to express this as a single log? So you know that plus is multiply, correct? So the first one you can see that is multiply is 3 times 3 times r, log 2. Agree? Try the next one, please. You've got a take away, you've got a plus. So deduct is divide. And you need to think about what is this. How do you take that back in there? So what happened? 4 log of 5p. Can we rewrite that as log of 5p to the power of 4? Yeah? And then the next one, what about q? Log of 5q squared. Right? Rewrite it that way. And then you can combine everything. So, this is how I do it. I rewrite. Now I now know that p to the power of 4 is divided by q to the power of 2. And then multiply by pq. Correct? And therefore, you know that is log of 5p, log of base 5, p to the power of 5 divided by q. C is slightly trickier. You've got a square root. Now, you also need to think about what happened here. 3 and 2r. Not going to say too much yet. Think about the cube. Are you going to cube the 2 as well?
Yes.
Yes, you have to. Because that will apply to the whole term there. I mean, the easiest mistake that I can see, I've seen things happen is people just write this as log of 2 to the power of 2r to the power of 3. Alright? But you do know that it's 8r cubed. Alright, you need to cube the 2, and then you can combine everything. So this is what I got. P squared over 8r cubed, q to the power of half. Alright? Do you all agree?
Yeah.
Yeah? Alright, now, example 2. Can you therefore evaluate using the idea that you've learned? Evaluate the following. Now, log 3 minus log 6, what does that give you? Log of what?
Half.
Ah, that's right, 3 over 6 log of half. Log of half is what? What is half in terms of 4? How do you write half in terms of 4? 4 to the power of?
Negative half.
Negative half, thank you. Alright, so straight away I can write down, because I know log 4 of 4 is 1. So therefore, I combine the next two, which is log of half. Half is 4 to the power of minus half, so it's 1 minus half, and therefore it is half. Now I'm going to quickly show you how to use your calculator a little bit later, alright? So the next one, I'm going to write this down so that I can remember. Log 4 of 4 plus log of 4, 3 minus log 4, 6. Alright, I'll need to show you in the calculator in a few minutes. So the next one, log, there's no base in there, means it's base 10. Alright, so log 10, base 10, what is that? That would be 1, correct? And what about this? 10 to the power of what?
Negative 3.
Yep. And 10 to the power of what equals to 1?
0.
So it should be something like this, right? So I'm going to get you to get your class pad out. Let's quickly have a look at how to use class pad for this.
Just type it in.
Probably, yeah.
Yep. Okay, let me write this down. Who hasn't got a class pad? Come and grab one from me, please. Class pad, everyone got a class pad? Class pad?
Not sure.
Alright, now,
No, bro, don't. I don't even know what's going on. So.
class pad under main. I'm going to get rid of everything first, edit, clear off. Alright, so go to keyboard. The first one, because there's a base of 4, you need this. Under math 1, log with a little box there and a big box there. Alright, so just tap on that.
You just write the exact same thing.
And then you just need to fill in, that is 4, log of 4, plus,
Ooh, natural log.
that's log 10. Hang on, that's not the other one. Log of 4, 3,
No way.
minus 4, and 6. Alright? Confirm the answer 0.5. Now, log 10 is one box lower. This is log 10. Alright? There's log of, can you any base, but that's log 10. And ln is natural log. We'll talk about that next week. So log of 10, log of base 10, you can use that. Alright? Slightly different convention. It's just log 10. So it's actually, I need a 2 in front. Or I can do it this way. 10. Oops. 10 times 2 minus log 10, 0.001. Alright, plus log 10, 1.
Oh,
Alright.
bro.
And there you go. The answer is 5. So the two things that you need to know: log of any base, log 10, and this is log natural log, which we'll talk about it next week. Alright?
Kim something.
Pretty straightforward at this stage using the class pair. Alright, next. The three, these are not in the formula sheet, but can you actually think about what the law number 4 is? 0, 1, and negative index log. So what would the first one be? Log A of A equals to 1. Log A of 1.
Yeah.
And then the last one.
Why is it B?
Negative something. I don't know. You don't know B though.
You don't know B. So, alright. How about I write it this way? You don't know B. Let me clear this. So, log. Yeah, it could be anything, but B to the power of minus 1.
Oh. So it's just whatever.
So,
Yeah.
remember log A of
It's just the negative of log of
whatever
Yeah.
to the power of n is n log A
Yeah.
of B. Alright? So therefore that becomes negative log A
Yeah. Okay. Yeah.
of B. Alright? So think about it, you're just playing around with the indices, that's all. So it's B to the power of minus 1. So B to the power of minus 1. Remember the proof I had for you? Log A of B to the power of n is n log A. So it's therefore minus 1 log A of B. Alright?
Yeah.
Six is a tricky one. Alright? The next one, we'll use
Oh,
it.
yeah.
Oh, no, actually, let's do example 3 first. So if you could express the following as a single logarithm. Alright? So you know 2 and log 2. So log is base 10, correct? So what would 2 be in terms of log base 10? It's log of
100.
100, that's right, log of 100. So it's log of 100 plus log 2. Right? So therefore, can you use your log?
Yes.
So it's 100 times 2. Correct? You don't actually have to simplify it or do whatever. Let's just leave it there. I want you to try the next one, please. Next one is a tricky one. Next one is a tricky one.
A plus B. Okay. Isn't it just log?
Can you see a p square at the end?
Yeah.
Yeah? So, this is what I did. So that equals log base 3 of 3 minus log base 3 of b minus log base 3 of b. Alright. Then, I can do it this way, can't I? If I take the negative out.
Yep.
So therefore, using an algebra rule, and that is log base 3,
Yeah.
3
No
over
base
p
there, though.
square. Alright? Oh, I missed a small 3 there.
Yeah.
It's not log 10. There should be a 3. Right?
Bro, you're just mathing today, yeah.
What?
You're just like,
Alright, next.
I do this every day, bro. Okay.
it's every
Now.
day, bro.
Huh?
This
Every
time,
day,
if a equals to
Just
log
be
3 and
jealous,
b equals to
Oh
log 2, can you think about
Shut
the
up,
following in terms of a and b? Let's look at 36 first.
Ever done before.
What is 36?
36 is 6 times 6.
6 times 6 or
2 times.
9 times 4.
Mm.
Because You want it in terms of 3 and 2, don't you? Yes, 6 squared is 2 times 3 as well, but then you have to work it out twice. 2 times 3, 2 times 3 twice. Whereas this one, if you look at it at 9 times 4, 9 is 3 squared, 4 is 2 squared. So therefore,
8 times.
that is log 3 squared plus log 2 squared. And it's 2 log 3 plus 2 log 2, which means 2a plus 2b. Try the rest first before I reveal my answer. D again is a tricky one. They're all a little bit tricky. Would you bring the square in?
No.
No, thank you. Because 24 is? Sorry? Oh, come on, Henry, it's not that big. 24 is only half a dozen, 2 dozens.
8 times 3.
Is 8 times 3, and 8 is 2 to the power of whatever, 3, right? Agree? So therefore, you know that is a 6b plus 2a. Try the next one. Oh, by the way, last night when I was preparing this, I realized that I didn't give you any homework from Friday, so I just uploaded it last night. What you need to do for Friday. So what is 64? 2 to the power of?
6.
Thank you. And 81 is 3 to the power of?
4.
Yep. And that's it. The next one is an interesting one. So I wrote it this way. 6.6 is 6 divided by 10. 0.8 is 8 divided by 10. Yeah?
Yeah.
And if I've done it right, this is it.
2b minus a.
Yeah? Agree? So I can now basically eliminate like log 10 because it's take away. Eliminate that. And therefore, that's the answer.
Wait, a over 2b.
It'd be log 6.
Have I got it right?
Wait.
Wait, is it a minus 2b?
I thought
Oh, a minus, yeah, it is a, hang on. It is a minus 2b, sorry, my fault.
Yeah.
A minus 2b, I was, oops.
Yeah, yeah, yeah.
Oops, it's a minus 2b, sorry, it's my fault.
This is just equal to log
It's a minus 2b.
6 over
Oops,
Yeah, I just did like because you
a
divide
minus
by-
2b.
I turned it to log 3.
A minus 2b.
Just use 6 divided by
Alright, so you can see that here.
really easy with that.
Mm.
It's like yeah.
Alright, here. So, remember, here you must put in a bracket. So therefore, I've got, starting from here, log 2 times 3, which is log 6, minus log 10. Log 10 of 10, which is 1. Alright? Take away log of 2 to the power of 3. Again, take away log 10 of 10. So, because this is one term, you must have the bracket, minus and plus. We got rid of that. So it's therefore log 2 plus log 3. Log 2 is b, log 3 is a, and then 2 to the power 3, take away 3b, therefore equals to a minus 2b. Alright? So D is actually a tricky one. Right, let's go to the next one. Now here, sometimes we need to change the base of a logarithm into a different base. It makes more sense when you solve certain type of problems. So this is something that you need to know. Log A of B. If I want to change it to base of C, it is log C of B divided by log C of A. Alright, write that down.
It says C of C.
Log C of A. I want to change both to log C. So log C of B divided by log C of A.
Yeah, how does that work?
It just does, bro.
It does work, but I'm not going to worry about writing it out.
It just does.
There is some proof. I will look for it.
Alright.
I'll look for it.
Is it in the formula sheet?
No, this is not in the formula sheet.
What?
This is not in the formula sheet. This is change of base.
What?
Just take it at face value first. I'll look out the proof for you. I'll look out the proof for you and I'll upload it.
Mate, log of C, B over A, so it's 1 over 6 over 6.
Alright, write this down. This is not in the formula sheet. It's just changing it to a different base, that's all. Alright, last one. Can you evaluate that?
Yes.
Last example. I think that's the last example.
Yes.
Yeah, it is.
Log B.
Instead of C, it's A. So you have log B there, you have B there, A there. So here's B, here's A. So log 1 of 6 equals negative 1.
Oh, so it's, yeah, it's already written in that form, so you go back.
Alright, I'm going to use B to actually explain the change of log. Alright? Now, let's concentrate on B for a minute. You know that, let's say, watch please everyone.
Rewrite this out and you'll see.
I'm going to explain now.
Oh, sorry.
So let,
He's explaining
if
it
I let,
for you. This is your question.
I'm going to use this to explain the change in base. So let A equals to log base 3 of 5. Alright? So therefore we know 3 to the power of A equals to 5. Agree?
I agree.
Now, if I take log 10 from both sides, log 10, 3 to the power of A equals to log 10, 5. Therefore, I know that A times log 10, 3 equals to log 10, 5. So therefore, A equals to log base 10, 5 divided by log base 10, 3. So therefore, you can see that log 3 over 5, if I want to change it to log 10, this is the process of doing it.
Why is yours
Alright?
5? 3 on 5.
Oh, wrong one. Alright? So this is how you actually change, why you change it and how you do it. That's a proof. I was too lazy to write that out last night, that's all.
Late night, so late night.
So that one is just basically minus 1 because log of A, 1 over 6 is minus log A of 6. So log of A6 divided by log of A6 is 1 and it's minus 1. I've done the second one for you. And finally, the last one.
Y equals 3 to the power of x.
So what is y? Y equals to?
3 to the power of x.
Yep, y equals x cubed. That's all. Alright? So pretty straightforward. Today's lesson, you need to be able to use all these rules. And I have uploaded some exercises for you to do.